Jai Hind to all. I am Priti Choudhary. I am assistant professor working in Akgec Engineering College in IT department. So today I will discuss my first lecture of data structure, that is classification of data structure, and why we need data structure use and what is data structure. So in this session we will discuss these points. So let's start. These points I will cover in this lecture. So what is data structure? Why data structure need, and classification of data structure, operation on data structure, and ATT. Mainly these points are today I will discuss in this session. So firstly, what is data structure? Data structure defined as a value, a set of a value. For example, like this, here data is a raw material and data used as a to format a records. So a person have some attributes. Maybe its name, maybe its age, name, age, address, any roll number, any identity. So these are the some data of this record. So these all data is maintained in any space is called a data. Or these data, name, age, roll number, या ID and address, all data record in different way is called a data structure. Like here, data structure is a way of organizing or storing data in the memory so that operation can easily apply on that data is called a data structure. So in our data structure subject, we use different types of data structure. First one is array, stack, queue, tree, and graph. These are some different data structure which is used this subject in data structure. So next one is start need of data structure. Why you need this data structure? Firstly, organize your data in different way. Then you can easily fetch your data in based on different operation. So that's why we need a data structure. Understand it to consider the real time example, so that we can say that that's why we use data structure. Like first example is queue at the ticket counter. So in a ticket counter, at a ticket counter, we use queue operation, queue data structure, and queue data structure basically work on FIFO operation, FIFO principle. First in, first out. Second one is the dictionary. Dictionary also work as a queue data structure because in a dictionary, all alphabet is stored as a ascending order, A, B, C, D, and all. Same thing is apply printer. Printer is also working as a queue data structure. Arrangement of a book in a library is working as a it's maybe a queue and it's maybe a stack. And second point is programming point of view. Program are converted into two. Data structure is way different types of, maybe it's array types, maybe it's linked list, maybe it's queue, tree, and graph. Plus we use the algorithm and data structure to complete a program coding. Next one comes to the next topic, that is classification of data structure. Classification of data structure means data is classified into two types. First one is primitive data types and second one is non-primitive data types. In a primitive data types means data is predefined. Here data is predefined, no user defined data. Let's suppose the example of primitive data types is int, float, character, and double. Non-primitive data types means here data is user defined data types, also called a derived data types. So non-primitive data types is also classified into two types. First one is linear and second one is non-linear. In a linear, we use these four types of data types. Data structure: array, stack, queue, and linked list. These all are a linear data structure. It means data is stored here a sequentially way. And second classified is non-linear data type. It means it is also classified in two types, tree and graph. Here data is stored in a random way, not a sequence. So now further explain these classification of data structure: primitive data structure and non-primitive data structure. Primitive data structure is predefined, as I earlier discussed in a data types. Here depend on machine dependent primitive data types. It's maybe on machine dependent on 16 machine in data types and 2 byte, and while 32 bit or 64 bit is used 4 bytes for integer data types. And non-primitive data structure is, it is a derived or user defined data types, also called a derived, and they are derived from primitive data types. So now comes to the operation on data types. Operation on data types, here are the different types of operation apply on different data structure. First one is insertion operation. Insertion operation means add the element of data structure, insert the element as a first element or last element, or maybe at a specific location. Here is called the insertion. You can easily insert any record, any data in given any types of data structure. Is called the insertion operation. Now comes to the second operation. Second operation means remove or delete any element from given any types of data structure. From given data structure, maybe delete the first element, maybe delete a last element of given data structure, and maybe delete a in between specific position from data, any kind of data structure. Now comes to the third operation of data structure, which is the widget traversing operation. Traversing operation means widget an element at least one times to perform the some specific operation is called the traversing operation. Like find sum, average, count, and search. These are used for traversing. Now comes to the next operation, that is searching. Searching operation means where to find whether the element is present or not in given data structure is called a searching. So this operation is apply different types of data structure. Next one is sorting. Sorting means is a method to arrange your data, arrange your elements in a particular order. It's maybe a ascending order or it's maybe a descending order. Next one is merging. Merging operation. Here the merging operation, we use two sorted list and transfer the third list. Merging of these two list and transfer into third list is called a merging. Let's suppose take the example of merging operation here. According to this, there is a two list. In this list having different types of records 2, 3, 5, 6, 7, 8. So here the two different sorted list and converted into one list from previous these two lists. So output is 2, 3, 5, 6, 7 and 8. So it's called a merging process. Now comes to the algorithm. What is the algorithm? Algorithm is the step-by-step process to solve a particular problem, a particular statement is called the algorithm. there are many way to particular problem to solve in by algorithm. It different way. It depend on different complexity. When we make the any algorithm to solve any particular problem, we create a algorithm according to check efficient algorithm, and it's maybe the choose any efficient algorithm among many. There are the techniques is known a complexity of algorithm. So criteria of algorithm, it means when we create any algorithm for any particular problem, solve any particular problem, we identify the some criteria to make any kind of algorithm to solve any particular problem. So first one is, these are the some 5 points. These are 5 points which is used make efficient algorithm. So first one is the input. When we create a make our any algorithm to solve a problem, so we have some inputs. It is the mostly outputs also required in all algorithm, because if any not output is given from your algorithm, then we cannot reach your destination point without output. So input and output both criteria is must in any algorithm. So third point is the definites. It means purpose of your algorithm is must. Finiteness, it means your algorithm means have some termination point, because in your algorithm have no any termination, so you cannot stop in future, and your algorithm is always time is running mode, so need any termination point. Okay, so next is effectiveness. Your algorithm must be effectiveness, because if your algo have complexity in time complexity and space complexity is very high of your algorithm, that time your algorithm not effective for to solve any problem. So when we make any algorithm to solve any kind of problem, so we we should have our algorithm is very effective also. Now comes to the complexity, means types of complexity of algorithm. That's why we can say that our algorithm is very effective or not. So we note these 2 points. First one is time complexity and second one is space complexity. Time complexity of an algorithm is the amount of time is need in the order of run to completion. So here we need the amount of time to complete your solve your problem. So here we need the amount of time. And space complexity, it means here we need the amount of space. Here we need amount of space to complete your problem. Now comes to the asymptotic notation. What is the asymptotic notation? Asymptotic notation based on mathematical estimation. Mathematical notation that allow us to analyze an algorithm's running time by identify its behavior of input size for the algorithm increase or maybe decrease. So this asymptotic notation classified into many types, but in this subject of data structure, basic data structure, we use only 3 types of asymptotic notation. So first one is big O notation. This is the symbol of big O notation. And second one is big theta notation. So this is the symbol of big theta notation. And third one is the omega notation. Omega notation denoted by this symbol. Okay, so these are the notations which is used to solve our problem. So now comes to the first notation, that is a big O notation. Big O notation provides the possibility asymptotic tightly upper bound Fn value for Fn value. Here the Fn value is always lie greater than equal to 0 and less than value is other value is that gn value. So let f is the non-negative function. So we say that fn is big O of gn is written this form. So it is the simple equation. Here fn value is always less than 0 and always greater than 0 and less than gn value. And c is the constant here. So according to these expression is also denoted by graph. So here fn value is always greater 0 and less than gn value. So comes to the second types of notation, that is big theta notation. Big theta notation, here we can say that fn is the big theta of gn, return fn theta gn if there is positive constant here to value, because here fn value is lie between two estimate values, gn value and gn2 value. So here fn value always lie between these two values. So here same thing, according to expression fn value is greater than 0 and gn first value and less than g2 value. So here c1 and c2 is the constant value. Now comes to the big omega notation. Big omega notation, this is the notation symbol of big omega notation. It provides the possibility asymptotically tightly lower bound of fn, and it does not give the worst case of complexity but can give the best case of complexity. Fn is said to be a big omega of gn, written as fn value is this form, omega gn value. If there are positive constant is here c and number of this. So this value is the of for big omega notation. Here fn value is always greater some estimate point value, that is gn. So now comes to the diagram. According to this diagram, gn value is a lower estimation of fn value. Now comes to the next point, that is ADT. ADT means abstract data types. It means present only simple view of any object but hide the implementation detail. Present only the simple view of any object but hide the implementation of detail. It the focus only what is this rather than how it is worked. So let's suppose we take the example of here TV remote. According to this TV, we can this presentation of this remote. Here we see the different types of button, different color types of button. Here we know red button is used for the switch on and switch off your TV, and this button is used change the channels. This button for use increase and decrease the volume. So you can see these buttons only from this remote, or you can know about the how it is work, but you don't, but the hide of the implementation or detail of this remote, ki how buttons work like that, like so this to start the TV simply press on without knowing the implementation. So same thing, from these buttons, different types colors of buttons, we can easily button on and button off on the button without any knowing implementation of this remote. So this is called the ADT. So this ADT is used the data structure also. It means array data structure, array ADT, linked list ADT, queue ADT, stack ADT, tree ADT and graph ADT. So means we can easily see how all types of data structure work, but how it is the implementation of data structure, like ADT of data types. Now comes to the second points of ADT. ADT represent the logical and mathematical model for any data structure. It's basically describe the representation of data and how to represent your data from any data structure. And operation can be performed on the without any implementation, कि कैसे हम implement कर पाते हैं. Now comes to the ADT of stack. Stack ADT means stack follow LIFO concept, last in first out, operation to be performed this. Here no need to require any kind of implementation. So this is the ADT of stack. We can easily check the represent your data here by this diagram. Okay, so this is the simple view of stack. Here you can insert some numbers in this stack 2, 3, 4, 5. So stack, now stack top is here. So this is the simple view of stack, and this is work on this concept LIFO, last in first out. Now we can apply the different types of operation on stack without use any kind of code. It's called the ADT. You can use on this data structure push operation. It means, let's suppose we have the value 1 is you want to insert the 6, so you can easily insert here. Only change one things in this data structure in stack. Top is change. If you insert any value in a stack, then top is increase always by 1. If you delete any element from stack, then your stack of top is always decrease by 1. So now stack value is 2. Okay, but if you want to delete 6, t value is here. If you want to delete 5, now t is here. Now if you want to delete 4, now t is here. So decrease by 1 always. Now comes to the pop. Pop is the for use delete. Push use for insertion operation. And pop is for use deletion operation. Okay, push and pop. Push and pop both are two fundamental operation of stack. Now comes to the third operation, that is peek. Peek operation, according to here, peek operation just the view of element which is present at the top is called a peek operation. Okay, view of last element of stack is called a peek. Let's suppose this is your stack 2, 3 and 4, and stack of t is third, and now you use the peek operation on this stack. So what is the output from this operation is 4, means last element of given data structure. Okay, next one is empty. Empty is also next operation of ADT, या next operation of stack. It means to check the stack is empty or not. Okay, is empty or not. So to check the whether stack is, how to check this operation, always return 0 and 1 value. 0 means false and 1 means true. If your stack value is maximum, it means if you create your stack size is 5, and here according to this you create the 0, 1, 2. So you create your stack in 3 size, or all elements already filled in this stack, and now you apply is full. Here the another operation is fifth operation is full. Okay, apply this operation on this data on this stack. So output is this true, because stack of type value is equal to given size. Okay, but in a MPT, if this operation is applied on this stack, output is false because some numbers are already inserted in this given stack. So in this session, we will discuss just a basic information of data structure, what is data structure, why we need data structure, types of data structure, classification, simple view of classification of data structure, and ADT of data structure. These are our operation on data structure. We only discuss these points. Next session, we will discuss about the in briefly classification of data structure one by one. Okay, so this time, thank you.